Okay, let's talk movies. Now, I love a movie. I love a movie theater, but it really changed the game when movie theaters put in recliner seats. I don't know who that genius was, but oh, chef's kiss. What a great idea. And that's something that this word problem talks about. So we have a movie theater that sells two types of tickets for a movie showing. There are stadium recliner seats that cost $18 each and regular seats that cost $15 each. And I don't know about you, but $3 additional is well worth being able to recline my seat and really live it up at the theater. The theater has a total of 40 seats, and when every seat is sold, the theater earns $648 in ticket sales. How many stadium recliner seats X and how many regular seats Y are there? Now, it may not be obvious, but we have what we need to create a system of linear equations within the words of this word problem. So we need to be able to write our two equations. And sometimes that can be a challenge. So what we want to ask ourselves, self, what are the two topics or constraints that are being talked about here? So one of the topics that we're talking about is cost. And another topic that we're talking about is the total number of seats. So one of our equations is going to have to do with cost. One of our equations is going to have to do with the total number of seats. And so let's focus on cost first. We know that stadium recliner seats cost $18, and we know that we are using the variable x for the recliner seats. So I could write an equation that's $18 per recliner seat plus $15 per regular seat. And when every seat is sold, we would equal a total of $648. So there would be our first equation. And our second equation would be for the total number of seats. So in this case, we would just have the number of recliner seats plus the number of regular seats. And we know that total, the theater has a total of 40 seats. So now we have our two equations for our system of linear equations. And we know that we can solve this by graphing. So let's go ahead and use Desmos. So I have Desmos up on my screen. I'm going to go ahead and go into graphing. And the great thing about Desmos is I can enter my equations exactly as I have written them in standard form. So I don't have to write them into y equals form like I would if I were using a TI 84 plus graphing calculator or something like that. So I can just go ahead and type 18x plus 15y equals, and then 648. And then I want to go ahead and enter my next equation. And you might be thinking, I can't see anything on your graph. We're going to address that, don't worry. X plus y equals 40. And so now you're looking at the graph going, that's great, but we can't see anything. Nope, we can't, because we're so zoomed in. And look at how big those numbers are. We have 40, we have 648. So we need to change our view. And so up in this corner here, I'm going to use my pointer here. Up in this corner here, we have plus and minus. And so we need to zoom out of our graph in order to be able to see it. So using those buttons, I have zoomed in, and by just clicking on the spot where the two, so the spot right here where the two lines intersect, Desmos does a really nice thing for us. Desmos will label the point for us. So using my zooming in and out buttons here, or if you have a touch screen, you can just simply use your fingers to zoom in and out. But if you are on your computer, you can use your mouse or your trackpad to just click the plus or minus until, and then adjust your screen until you can see the lines that you need to see, and you can see where they cross each other. And then, like I said, by clicking on their point of intersection on Desmos, Desmos will label that point for you. So what does this point tell us? Remember that our first number is our x value, and our second number is our y value. And remember, our x value was our number of reclining seats. So that tells us that there are 16 reclining seats and there are 24 regular seats in this theater.